This video, I'm just going to show you how to create a homing missile in Unity3D using C#. Before I jump into any source code, let's just see the end product, what it's going to look like. So here it is. The missile just follows me around. I can move left, I can move right. It's still going to follow me around. I can jump all I want. I can jump off the map even. It's still going to follow me. The only way to shake this missile off you is if you jump at the correct timing when you're within a sweet spot range. So notice when it's close enough to me, I get this prompt that says space telling me to jump. And if I jump when I'm prompted to, we break the lock and the missile just goes in the direction it was going prior to the dodge. Notice one more thing. So when I jump, I can collide with the missile again. It doesn't hurt me anymore. It's completely pacified. I've noticed quite a few games do this now. For example, like the recent Spider-Man game, if you dodge at the missile at the correct timing, it's completely pacified. It can explode right next to you, and it won't kill you. But if that happens, it'll explode next to you. It will hurt the enemies that are around you. So I took some inspiration from that. You can just redirect the missile back at the guy shooting it. So yeah, let's just jump into the source code now. So here's the source code. There's probably going to be a link to this to my GitHub, so you can check it out for yourself. Let me zoom in a little so you can see better. So these are just the global variables. The start method, just initializing the components that I'll need. Nothing too difficult here. Let's look at the function that has the logic for homing. So it's called follow player. The first thing that we do is that we get the target or the player's current position. So we subtract that vector by the missile's current position, and then we normalize it. So normalizing is just dividing the each component of that vector, ijk, by the magnitude. After we get that, we get the direction. We use the direction to rotate the missile to face the player. So that's what this line does. And then we multiply the direction by the speed and delta time. Speed can be whatever you want it to be, how fast you want the missile to be. Delta time is just the time that's elapsed since the current frame and the previous frame. So like if a lot of time has elapsed, then we need to move more. If little time has elapsed, we'd have to move less. So what that gives us is the incrementation we'll need in terms of like the vector, our current position, to get closer to that player. So we just increment the current position for this frame by the incrementation that we'll need. And yeah, so each frame, the missile will get closer and closer to the player. Alright, so let's look at our fixed update. So I have a boolean called isLockedOn. By default, it's set to true. So as soon as the missile is instantiated, it's going to start following the player. So isLockedOn, it's going to follow the player. And then I have this line here. If the missile's in the sweet spot and the player is on the ground, we're gonna do this stuff. But before I explain this part, let's look at is in sweet spot. It's a very simple function. All it does is that it gets the distance. It applies the distance formula to the missile's position and the player's position. And if that distance is within a certain range, we'll return true. If it's not, false. So if the player's in the sweet spot, we'll activate a prompt to jump. And if they're in the sweet spot and they also happen to press the space button while they're grounded, that means they've jumped and successfully dodged the missile. So we disengage the homing. isLockedOn is set to false. So in the next frame, when isLockedOn is false, we'll just skip this block. We won't go into here, and so we're going to go into the else block. So what happens in the else block? Well, we're no longer using the follow player function. Now we're just going to move in the direction that it was going prior to the dodge. So notice this function this line looks very similar. It's basically this line right here. But instead of like normalizing the direction, we just move forward. And I think transform forward is already normalized, so we don't have to do that. And what this line does is just makes the missile keep going in the direction it was going. So I have another boolean called prime for self-destruction, because after the missile's been dodged, it's just going to keep going on where it was going on its path. We don't want the missile to just like still exist. It's going to create clutter in our scene, even if like it'll just slow the game down. So we want to get rid of it. So what we do is that first we turn off the prompt if it's still active, and then I change the game objects tag to rogue projectile. By default, it's set to enemy, and the way I have it set up right now is anything with the enemy tag hurts the player. I don't want the missile that's been already dodged to hurt the player anymore. So I change the tag. Then I ignore all collisions with the player. So if the player collides with it, or if the player touches it, again after it's been dodged, the missile will just go through the player, as if they don't even exist. So we do that, and then we set a timer to destroy the missile. So I have it set to 5 seconds. So if it's been a rogue projectile for 5 seconds, it just deletes itself. And I also set the boolean value prime for self-destruction to true. So in the next frame, it won't go into this block. We don't want to do all this stuff again. And it'll just keep going in the direction. It'll just execute this line. You can use rigid body instead of transform, but I don't really care too much about physics. And when that's not important, calculating the physics for each frame actually, pretty sure it slows down the game, reduces performance. But yeah, you can use rigid body if you want. I like to use transform. Yeah, and check out the source code for a more in-depth view of this.